In this video, we will talk about how to manipulate text data in VBA using tools such as operators and string functions. Text data is represented as a string data type in VBA. There are two string data types, variable length and fixed length. And note that there is a subtype string within the variant data type as well. String data types consume upwards of 16 bytes of memory. The default value of a variable with a string type is blank or an empty or a zero length string represented as two consecutive double quotes. And if we want to convert a different type into a string type, we can use the cstring type conversion function. Consider the following text. Raw data values entered within our code are called literals. And since this value is of a string data type, it can even be called a string literal. We can use the ampersand symbol to join two strings. This is called concatenation. So wrap the first part of the text in double quotes, followed by an ampersand, and wrap the next part of the text in double quotes as well. Play the macro. It gets printed out as a single text, and notice the space in between, which we have physically added in the second string. We'll talk more about concatenation later on. A single element within a string is called a character. So capital W is a character. This makes string a sequence of characters. VBA strings can accept a set of 256 characters ranging from codes 0 to 255. And note, we are not referring to how many characters can fit within a string, but rather what value can be held within a single character. On display is an assortment of characters with their character code. We can see single lowercase alphabet, uppercase alphabet, number, and special characters. We can use the character function to return back the character using its associated character code. Let's print the character for the @ symbol, which is given by the code 64. So we use the chr function followed by the character code. Play the macro. We get the @ symbol. Now suppose we want to enclose the phrase VBA master class within double quotes. That is, we want the printed value to look like this. Now we've already mentioned that we need to write any text within our VBA code within double quotes. If we try to add another double quote, so like this, we will get an error because VBA will consider it as the end of the previous part of the existing string. So instead, we can insert or rather concatenate the character double quotes as derived from the character function. So this is the first part of the string. Let's add a double quote given by the character code 34, which will join to our phrase VBA master class, enclose the phrase in double quotes, and add in a physical double quote at the end. Well, actually on second thoughts, we should add it prior to the full stop. So close our string here and the character code 34. Again, and wrap the full stop in double quotes as well. Okay, let's play this out. We have another way to add the double quote character as well, which would be by adding two consecutive double quotes. So add two double quotes out here and two double quotes before the full stop. Okay, we didn't get an error, so that means VBA accepted this. Let's play this out. We get the same phrase. Let's say we want to print welcome, and this is the VBA master class, each on a separate line. We can insert the character for a carriage return and a line feed, which basically places the next line right below the previous one. The character code for carriage return is 13, and for line feed, it's 10. So let's end the first part of the string at welcome dot, add a carriage return and a line feed, and concatenate it to the next part of the string. And since both phrases are on separate lines, we can take out the space. Okay, that looks good. Let's print this out. And both phrases are on separate lines. We have predefined constants which also give us the same result. We can use the constant VBCRLF for carriage return and line feed. So instead of these codes, we can use the constant VBCRLF. Let's run the macro. We get the same result. And we have the VB new line constant, which gives us the same result as well. Knowledge of how to break a string into separate lines is important when trying to fit larger strings into a confined space, such as a message box. So let's output this text inside a message box. Run the macro. This looks pretty neat compared to the original single string. And knowledge of character functions is important when reading data from an external source such as a text file. For example, the file can have hidden characters such as a line break, which won't be displayed visually to us. There are two kinds of string data types, fixed length and variable length. In the vast majority of cases, we will use variable length strings. Nevertheless, let's look at both these types. Fixed length is where the length of the string is determined at compile time. It can contain 1 to 64k characters. So if we want to create a variable that will hold a fixed length of 20 characters, we need to specify the length in the declaration. For example, this variable is a fixed length string with 20 characters given by the asterisk sign, and we define this within the declaration itself. Now let's assign this variable a value, and we'll print out the value within double quotes. Let's print it out. We can see that the remaining 13 characters of the 20 character string is filled out with empty spaces. Next, we'll look at variable length string types. We don't need to specify their length at the time of declaration. A variable length string can contain up to 2 billion characters, and a variable string is simply declared as a string. So this time the string greeting variable is declared as a variable length string. Let's print it out. And the length of the output is the same as the length of the variable value. We can return the length of a string using the len function, which returns the number of characters within a string. Let's print out the length, and the length of the string is 7 characters. In the rest of this video and this course as well, when a string type is mentioned, we will only be referring to variable length strings. A variable declared as a string type will have the default value of an empty string. So here we're simply declaring a string variable but not assigning any value to it. Let's put a breakpoint at the end sub statement, bring up the locals window, play the macro. The default value of a string type will be visually represented as a double quote followed by another without any spaces or any other characters in between. An empty string has a length of 0. Print this out. We get 0. A common task in VBA is to check whether the string variable has been populated or not. Let's look at an example. This is a contact details form. The email address input field B4 is a mandatory field. If it's not filled out, we want to display a message to the user, prompting them to fill out the field. Let's build the code for that. We will read the value from the cell and store it within a variable. Now for our test, we will use an if statement to check whether we have populated any value within this email ID variable. The most intuitive way to check whether a string variable is empty or not is to check if it is equal to the default value of a blank string, which is simply 2 double quotes. If this condition is true, meaning no value is populated into the variable, then we will display a message and exit the sub. And let's just put some comments in, which is just a proxy for code that we could execute if the email ID was not blank. Run the macro, we get a message. Now, if we are looping over a data set where we need to perform the empty string check over thousands of rows, then a faster way would be to check the length of the string. So if the length of the string variable is 0, then we'll populate a message. Run the macro, we get the same result. A high-level explanation for why this method is faster is that a string value is stored in computer memory with the length of its string placed at the beginning, which means it's faster for the variable pointer to get to as opposed to checking the entire stored text value. Hence, the length function gives us a faster result. And yet another way to achieve the same result is to compare it to the constant VB null string. Run the macro, same result. Despite the different methods, I still prefer checking for an empty string, that is the 2 double quotes, as it makes the code more readable even though it's less efficient. We have already looked at one way to join or concatenate strings, which is by using the ampersand symbol. Another common way to concatenate strings is to use the plus sign, which is also the addition symbol. Let's print out the statement to make sure we get the same result. Yes, we do. However, this plus operator is tricky when mixed with non-string types. For example, adding a numerical data type will give us a type mismatch error. And that's because 3.4 is a floating point number. To perform a meaningful concatenation, we need to convert this value into a string using the type conversion function. And that should work. And that being said, I would suggest to just use the ampersand signs when performing string concatenation to avoid any confusion. Suppose we want to extract certain parts of a string. A part of a string is called a substring. Here we have an employee ID, and for our first task, we want to extract the employee number from the string, which we know is the last 5 characters. To do this, we can use the write function. We're going to search within the constant employee ID, and we're going to grab the last 5 characters and then print out the employee number. Run the macro, we get the employee number. And if the employee number was on the left, like this, we could use the left function. Run the macro, and we get the number. Now suppose the number is in between. First, let's consider the scenario where we know for sure that the employee number starts from the 5th character and is 5 characters long. To extract the employee number using these given parameters, we can use the mid function. First, we need to specify the point at which our substring will start, which is at the 5th character, and then the length of the substring that we want to grab from the 5th character onwards, which is another 5 characters. Okay, let's run a macro and we get our employee number. So these last 3 examples were cases where the position of the substring is fixed or known to us. But what if we don't know the exact position but do know some rules? For example, for this employee ID construct, suppose a rule is that the employee number is between the 2 hyphens, so this one and this one, within the employee ID. So how do we extract the employee number now? We will check out a hard way, or rather more manual way, and later an easy way to find our substring. We will start with the harder way. What we'll do is locate the positions of the 2 hyphens and use that to construct the mid function. We can use the InStr function, which is used to find the position of the first occurrence of a substring within a string. So let's declare a variable to hold the value of the position of the first hyphen. For the first argument, we can provide the position from where we want to begin our search. We want to start from the beginning, which is 0. And if it's 0, we can omit mentioning it. So let's directly add the string within which we want to perform our search, which is the employee ID. And what are we searching for? We are searching for the first occurrence of a hyphen. Let's just print out the value to see what we get. I'll just comment this out. Run the macro. So the first hyphen occurs at the 4th character, but the start position of our employee number is the first character after the hyphen. So what we'll do is store the starting position as the position of the first hyphen plus 1. Next, let's search for the second hyphen. This time, we need to specify the start position to avoid returning the same result as the first hyphen. So we need to start the search from hyphen plus 1, which is basically just this starting position variable. And the rest is the same as up here. And let's print out the second hyphen position to see what we get. Run the macro. The second hyphen occurs at the 10th character. We can even search in the reverse order using the InStrRev function. So we are now searching from right to left, which basically means that the starting position is 0. Let's print this out and we get the same answer, which is 10 character. Now remember, we need to populate the substring start and length values back into this mid function. So the length of the substring will be the position of the second hyphen minus the start position. Let's just bring this down, declare another variable for the string length. And let's print out the string length to make sure our calculation is correct. We should get the answer 5, and that's correct. Okay. Now let's construct our mid function. Let's uncomment this block of code. So let's start writing our mid function again. We need to provide the start position of the substring, which is the start position variable. And we need to provide the length of the substring, which is the string length variable. And remove this debug print statement. Okay, that's it. Let's run our code and we get our employee number. Okay, so that was quite a few steps. It was a good example of how to create a complex formula using variables. There is an easier way to get the same result, especially in this particular case. We can split this employee ID string into different parts based on the hyphen. What we will get is an array of split elements. An array is a list similar to a collection. The first element within the list or array will be the text emp. The second element will be the employee number, and the last element will be the text tab. And what we are after is the second element. Let's remove all of this and start from the beginning. Let's declare a string array variable. We'll learn more about arrays in a later lesson. We'll assign the output of the split function to our employee split array. What are we splitting? We're splitting the constant employee ID. And we need to specify the delimiter that we want to perform the split on, which is the hyphen. And the employee number will be the second element within the employee split array. To extract the second element, we need to provide the index number of that second element within the array. Arrays in VBA are indexed from 0 unless specified otherwise. So the second element is at index 1. Okay, that's it. Let's print out the employee number, run the macro, and we get the employee number. Great. And one more point on the topic of manipulating strings. Suppose the employee number within this employee ID doesn't have any preceding zeros. So something like this. And suppose that when printing out the employee number, as in out here, we want to display the value with preceding zeros such that the maximum size of the employee number is 5 characters. So in this case, we need to add 2 characters or 2 zeros to our existing 3 character string. This process is called padding. Let's declare some variables. I'm just going to paste them in. So we're going to continue to extract the employee number from the employee ID using the split function. What will be extracted is the 3 character string. The length extract string variable will be the length of the employee number as is from within the employee ID. Let's print out the length. It's a 3 character string. But what we want to do is create a 5 character string and we'll hold the number 5 within this variable. So the length to pad will be the length of the desired string minus the length of the extracted string. And let's see what we get. We get 2, which is correct. We can use the string function to create a string of repeating characters to the length that we want. We want to create a string of 2 zeros that we can add in front of the extracted employee number, and we'll hold that 2 character string within this padded zeros variable. Use the string function. We want to create a string of the length to pad. And what is that string going to be made of? It is going to be made of repeating zeros. Let's confirm what we get. We get 2 zeros. That is correct so far. And now we just need to concatenate the 2 strings and reassign it back to the employee number variable. So what we will do is get the employee number to equal to the 2 padded zeros plus the original employee number, which is 131. And just note, it is common practice in VBA to assign a value to a variable based on its previous value. Okay. Now we can print out the employee number. Let's see what we get. And we get 00131. Let's remove one more number from the employee ID. So now we should get a string with 3 padded zeros. Let's see what we get. And we get 3 zeros and 1, which is correct. We can also use trim functions to remove leading or trailing spaces or both. Consider the following string. To remove all the spaces on the left, we can use the ltrim function. And to validate our result, let's put it in within double quotes. Run the macro, no spaces. We also have the rtrim or right trim function to remove spaces on the right, and the trim function to remove spaces on both the left and the right. So suppose we have spaces on both sides. Let's use the trim function now. Run the macro and we get a result. Trim functions only apply to before and after the first and last character of a string, but not within. So consider the following string. To extract the employee number, we can replace each space with an empty string using the replace function. So let's specify what we want to replace. We want to replace a space character with an empty or zero length string, which is simply 2 double quotes. Let's print it out and we get our employee number. On a slightly different topic, within string manipulation, we can change the case of an alphabet. The uppercase function will return all characters in the capital form. So the uCase function will capitalize every letter within John Doe. We also have a lowercase function which does the opposite. We can even change a string to proper case where the first letter of every word will be capitalized. And we can use the string convert function for this operation. We need to specify how we want to convert the employee name. We have various options given here by the different constants. We have lowercase and uppercase as well, but what we are after is the proper case. So let's select that, run our code, and J is capitalized and D is capitalized. Great. We can use comparison operators to compare strings. The result will be true or false. Let's start with the test of equality. So here we're comparing John with a capital J versus John with a lowercase j. Let's run a macro and we get both names are different. This is because we are performing a case-sensitive comparison method called option compare binary. The option compare statement can be declared at module level. The binary method is the default. If we see no option compare statement at the top of the module, then every string comparison will be case-sensitive. We also have a case-insensitive method called option compare text. This option statement must appear at the top of the module before any procedures. So let's add that in. Now we'll run the macro and the equality condition is satisfied and we get the result, which is that both names are the same. These comparison settings were on the module level. We even have local settings within certain functions. For example, the InStr function, which we saw earlier, also has a comparison method. So first, let's remove this statement. We will search for the starting position of the word John within the name John Doe. Note, there is no option compare statement at the top, which means that the binary or the case sensitive method is the active one. Let's run the macro. The result is 0, which means no match was found. Okay, now let's specify the compare argument by adding a comma and then choosing VB text compare, which also has the value of 1. Now understand this. The module level comparison method is case sensitive, but the function level comparison method is case insensitive. Let's run the macro. The function level setting overrides the module level setting and we get a match for the word John starting at the first character. Another example is the string compare function, which compares two strings and returns a 0 if they match. Run the macro, we get -1, indicating that the first string is lesser than the second string. Our takeaway here is that it's not 0. Let's add in the compare argument, run the macro, and now our result is 0, which means both these strings are equal. We can also match for patterns within a string using the like operator. Let's look at the following table for our available options. We can match a single character, multiple character, or a range of characters. So remember, we are still in the case sensitive mode. We'll ask the question whether the word John begins with the letter capital J. So like matching J and then asterisk to match 0 or multiple characters after J. Run the macro. The result is true, indicating that John does begin with capital J. Let's do a handy check. Let's check whether an email address is valid. So like, we will check whether it contains an @ symbol anywhere in between the string and the word .com at the very end. So like asterisk @ the string .com and close the double quotes and run the macro. That's true. Let's put in another symbol. Run the macro. We get false, which is correct as well. Let's look at the following code that will open a file only if the file name given out here, represented by the file name constant, is an Excel file. Excel file always have the extension suffix as XL, be it a normal or a macro file. So let's try to open this file within this folder, run the macro, and a file opens. Let's change this file to a Word document, run the macro, nothing happens because this condition did not evaluate to be true since the extension that we had provided was a doc file and this workbooks.open method wasn't played out. We can check whether a character belongs within a set of characters. So here we're checking whether the student's grade is either A, B, C or D and the character list is given between 2 square brackets. If the grade is any one of these characters, then we will print out passed and else we'll print out failed. Here the grade is A. Let's run the macro. We get passed. Let's change the grade to G. Run the macro. We get failed. And for a continuous range of characters, we can use a hyphen. So let's test it out for grade C. Run the macro. We get passed. And in the last topic of this lesson, we will look at the format function, which can convert any data type to a specially formatted string based on a set of instructions that we provide. So consider this following date. Let's specify a different format to display the date. We're going to format the start date constant and let's specify the format in which we want to output the date. Run the macro and we get a result. There are many more options available within the format function and date types. We will look at these in the lesson on date types. We can format numbers as well. So let's return a double as a string within the default currency format and specify the format name, which is currency. Run the macro and we get the default currency format. We could even achieve the same result by specifying our own custom currency format. Run this code. We get the same result. And that's it for this lesson for working with string types. A single element within a string is called a character. The most common type of string that we will use is the variable length type. The default value of a string is an empty string. And the best way to check whether a string is empty or not is to check its length using the len function. We can join or concatenate strings using the plus sign or the ampersand sign. Use left, right, mid to extract parts of a string. Use InStr or InStrRev to search and compare substrings within a string. We can even use the like operator and the string comp function to compare strings. To change the case, we can use the uppercase, lowercase, and string convert functions. And to force any type into a specific string format, use the format function. In the next video, we will deep dive into ways of working with the date data type.